Hello, hello. My name is Geronimo Mendez,
I'm George Sanchez.
and we're presenting CECS326 Lab 4.
This is the multiple thread labs, the one with the two villages. We were given to implement a two village freeway, one way road, and the problem that was presented was that if a village is on the east side driving towards the west side, people from the west side driving towards the east side can't get on because obviously they would have a crash. And we decided to use synchronization tools, more specifically the synchronized and the conditional variables. As you can see, if we go to traffic control, this is where we actually just started the threads, and we called one West and East Village, and we made 5 drivers, and we decided to differentiate West and East by the number 0 and 1. And within the implementations of the threads, we had East Village, which basically just the implementation just basically starts the thread and then prints out calls each function for the thread. And the main is basically in the traffic control. No, driver implementation. My bad, driver implementation. And here we decided to write a few synchronized functions that would hold a count and the Boolean variable on whether each village was on the road or not. We had a counter coming down saying that if the count is 0, then the other side could drive. That way we could stop them from going into each other. We also had two Boolean variables saying that, which village is on the road. We also had a counter up just in case starvation occurred. We did allow for the next the next type of threads to
Take a turn.
take a turn. Exactly.
Yeah.
Do you have anything to add, really?
Yeah. So basically, like George said, we're using conditional variables in order to make sure that we don't have two different villagers from different sides on the road at the same time, as that will create a jam,
Deadlock, yeah.
deadlock,
Deadlock, yeah.
and so yeah, we gave signals to each side, and we implemented the two villages basically the same, just making sure that they all take a turn, and also not just so that one side of the village is too long on the road, and yeah, they take turns. So here I'm gonna compile the code and running. Okay, let me stop this. Okay. Alrighty. So I'm gonna just go to, for example, here, we have West driver is, let's start here. The West driver 0 is exiting the highway. It's allowed to check. And once it checks that it's clear, it can go ahead and drive.
It can
And
either drive, eat, or listen to music. Or no, what was the other one? Drive, eat, or
eating.
oh yeah, eat. Yeah.
Eating. So once we realize that, hey, driver, the west side villagers are hogging the road, they must exit. So they could check, they're allowed to check, but not into the road.
Yeah, because we reset the boolean so they all have a chance to enter the road again. But just in case of starvation, we did give a opportunity for the other drivers to get on the road.
So as you can see, now the east drivers can go take a turn, as you can see here, after the west driver exit the highway. And yeah, now they all have a turn.
And once all, as you can see in the program, all west or east drivers have to be off the road for the east drivers to actually get on the road.
Yeah, so they must exit all from the west, and they're allowed to check if there's anybody, but in order to decrease starvation, we made a function to make them exit out. And this is their project. Thank you.
And as far as what we learned from this project was that actually having synchronized threads is actually a pretty difficult task, just because you really can't predict where a multi-threaded or like parallel driven program will take you, and you really have to think about all the possibilities of to be able to control the flow of the program. And it was pretty interesting to have to think in that way.
Yeah, that is all. Thank you.
Thank you.